Hive, AWS Glue, Azure Blob, and Google Cloud Storage are all metadata catalogs. What are metadata catalogs and why do we need them? The big data era started with the bomb. We don't need relational databases. We can just store things on raw files and we'll query them. But soon enough, people wanted back some structure. People wanted to query the data just like the query database. So the solution was, okay, let's add a layer of metadata on top of these raw files. Let's specify what are the columns. And in the future, there were more advanced things, but this was the basic things. The basic things was that now, if an analyst wanted to query the data, he would write an SQL. And how would this SQL know where the data exists? It would go to the metadata catalog, and the metadata catalog, what would be its backend? Usually its backend was a relational database like PostgreSQL or MySQL. So in order to know what is the location of the S3 file, and just to write plain SQL files with standard columns, select bike from bikes where the bike price is larger than $1,000. We need to know what is the table. Where is the table bikes? What does it mean bikes? What is the column bike? We need to know table and columns. Reminds you something? Yes, relational databases. So Hive Metastore, and this is why it's called a metadata catalog, the Metastore. The Metastore is a store on top of the store that stores the catalog. So Hive collected all this information. You need to define it. Where are your data? Then you could just run SQLs. And now the question is when to use the Hive Metastore and when to use Glue Metastore for that sake in AWS or other Metastores. So basically, if you're already in the environment, already in the cloud, in some, let's say in AWS, then it makes sense to use Glue because it would automatically connect with the antenna and with other services, and you wouldn't need to install anything. It's practically serverless versus Hive where you would need to install it. So it's going to be simpler to use, not necessarily have all the feature and vice versa of the other Metastore, but this would be the common sensible thing to do, to use this Metastore, for example, the Glue in AWS. We need to check some edge cases. For example, how many partitions can we have? If we partition by hour, then how many partitions could we have? For example, some people have reported facing in different Metastores facing a limit, and only when they switched the backend database of the Metastore, only then they would be able to go beyond this limit. Glue also has additional features such as crawlers that would crawl the data and automatically create the Metastore. And Hive would have other features that do not exist in other Metastores, such as the ability for transactions, for authorization, for automatic column statistics, such as mean, max, average, and so forth. The API of both Glue and Hive are compatible. So for using the API, adding tables, editing them, the API is practically the same. So in general, we have some open source tools such as Spark, Presto, Hive, and if we live in the cloud, then specifically for Hive, we're going to use the Glue. Note also that some of these Metastores, specifically we know that Hive, when you deploy it, when you manage it, you need to provide it also with a deployed relational database such as PostgreSQL. Glue is here since 2017. And since we have this HDFS, which is a low-cost data store, and people needed to run these SQLs, people needed to get some metadata about the data, then we needed something to provide us with the scheme, the tables, the column, the ordering, and how to do joins in between of these tables. So this is where Hive AWS Glue, Azure Blob, and Google Cloud Storage all came to solve this problem.